So today's notes are on polynomial long division. And polynomial long division is actually one of my favorite things in algebra because I think it's really cool that long division is something that you guys learn how to do in elementary school, and then it actually connects to polynomials in a really nice way. So first, before we get into long division and polynomials, I just want to do a quick review of division basics. So bear with me for a minute. I know this is going to seem really simple, but it's going to help us when we think about more complex problems. So if I take 8 and I divide it by 2, right? We have our old school division symbol. We know that this is 4. And we have some other representations we could use here besides the division sign. We could do 8 over 2 as like a fraction, and that is also 4. And lastly, you can do the division. I know this has a name, but I forget it. I'll tell you guys next time I see you. But you put the 8 in the inside, you put the 2 on the outside, and 2 goes into 8 4 times, right? And so these are all of our ways of representing division. And we also know that if 8 divided by 2 is 4, then we also have 2 times 4 must equal 8. If one is true, the other is also true. Now, quickly, I just want to also do one old school long division problem to remind you of how it works. So in long division, say let's do 3 divided by 87. So to start things off, I'm thinking how many times does 3 go into just the 8? Goes into 8 2 times. Now I do 2 times 3 to get 6. I subtract 6 from 8, I get 2. Bring down the 7. Now I'm thinking how many times does 3 go into 27? 9 times. So that means that 87 divided by 3 is equal to 29. Also means that if I checked, I did 3 times 29, I would get 87. Okay, so in the next section of our notes, we're going to think about how do we understand division when we're looking at variables. So the first example I have for you guys is x to the third divided by x. Now, right as it is in kind of an unfamiliar notation, but we could rewrite this as x to the third divided by x or over x in a fraction, and now this looks pretty familiar, I would hope. We can think about exponent rules, and remember x on the bottom, that x on the bottom is really like an x to the first power. So x to the third over x to the first, I can do x to the 3 minus 1. That's what exponent rules tell me, which is x squared. So that's telling me that the answer to my original question, what is x to the third divided by x? It's x squared. And another way we can denote this is we can use the old school long division process. We can put x to the third inside the bar, put x on the outside, and how many times does x go into x to the third? X squared times. Okay? So if we move on to the next example, 2x plus 4 divided by 2. So if I rewrite this as a fraction, 2x plus 4 divided by 2, well, this is something we should know how to simplify. We're dividing 2 into 2x, so that would leave me with an x, and then 2 into 4, that would give me 2. So we know that 2x plus 4 divided by 2 is equal to x plus 2. If I did this using the division bar, I would put my 2x plus 4 inside, the 2 goes on the outside. And now how many times does 2 go into 2x? It goes in, well, 2 times what gives me 2x? It has to be an x. And now I'm thinking about long division, right? So remember the next part of the process is to multiply that x by the 2 and write it down below. So here I can multiply by 2 times x, I get 2x, and now I'm subtracting. Well, what am I subtracting? I'm subtracting 2x from 2x, that's just 0. Now if I just use my parallel process to when we're doing long division with numbers, next thing to do is to bring down the 4. Right? So I have how many times? Now I have 0 plus 4, which is 4, so how many times does 2 go into 4? Twice, so I'm going to put a plus 2. And this gives us the same answer of x plus 2 as we got before when we were thinking about it as a fraction. Okay, so you're finally ready to take a look at a true polynomial long division problem. So this one is x squared plus 5x plus 4 divided by x plus 4. So I'm going to set it up the exact same way with the long division bar. I'm putting x squared plus 5x plus 4 inside, and I'm putting x plus 4 on the outside. So, and when I do this, I'm going to only think about the x in my x plus 4. I'm going to kind of ignore the 4. So first, I'm thinking, how many times does x go into x squared? So x goes into x squared x times, right? Because x times x is x squared. If you're not sure about that, you can off to the side think x squared divided by x. Yes, that would be x, right? So when I write this x, I'm going to align it with the 5x because I'm going to kind of keep my x's in the same spot, like in the kind of like place value. Okay, so now the next step in long division tells me to multiply the x by x plus 4. So if I multiply x by x plus 4, I'm basically doing distributive property. So x times x gives me x squared, and x times 4 gives me 4x. Okay, so the next step now in long division is to subtract what I just multiplied from what's directly above it. So it's really important that you put this in parentheses so that you remember that you are subtracting, and you should be very careful with your signs here. So I'm doing x squared minus x squared, which is 0, right? That's going to cancel. And then I'm doing 5x minus 4x, which is 1x. And then I'm going to bring down the last term in my polynomial, which is 4. Okay, so now I'm thinking, what is, or how many times does x plus 4 go into x plus 4 down here, right? And, well, they're the exact same thing, so how many times does something go into itself? Just one time. So I'm putting a plus 1 up top, and then what is 1 times x plus 4? It's x plus 4, right? I can subtract here, but I'm just going to get 0. So there is no remainder. Now we can always check our work to see if we did this correctly by multiplying, right? Because if x squared plus 5x plus 4 divided by x plus 4 is x plus 1, it means that x plus 1 times x plus 4 should equal back to the original polynomial. So if we multiply this out, and you can decide if you like the box or if you like to FOIL or whatever your preferred method is. So we should get x squared, 1x, 4x, and 4, which gives us x squared plus, what do you know, 5x plus 4. So we know that we did this correctly. Alright, so that concludes this example, and I just have one more problem for you to try it on your own. And if you're totally confused right now, don't worry. Do your best to try to set things up and see if you can at least get started on this problem. And we're going to be practicing in class next time I see you.